So let's continue. Remember this 5% guideline? When we talk about the sampling method, we have sampling method without replacement and the sampling method with replacement. So with replacement means all the selections are independent, but without replacement means the selections are dependent. But we have this 5% guideline. If the sample size is very small and the population size is large, let's say we have this rule. If the sample size is no more than 5% of the population size, then we treat all the selections as independent, even though they are actually dependent. So that we can use this guideline when we have the problem about binomial distribution, because the second requirement for the binomial distribution is all the selections should be independent to each other. So sometimes the selections are without replacement, but if the sample size is very small, we can still treat them as independent selections. So let's talk about how to find the binomial distribution probabilities. The first method, we will use the formula. So this is just the formula. How can we get the probability for binomial distribution? So in this formula, we will need several values, right? The first value we need is n. Remember what is n? That's the number of trials. That's a fixed number. How many trials are in total? So this is n. Remember what is x? X is how many successes do we have? How many successes? That's the number of successes. And we also need to know what is the lowercase p and the lowercase q. So p is always means the probability of a success, and q always means the probability of a failure. And we need to know the relationship between lowercase p and the lowercase q. We have p plus q is equal to 1. This is always true, right? You can check here. So if you know p, you automatically get q. So this is the formula. When you do the probability, you need to use this formula. Let's go back to the example. So in this example, we already know the results follow the normal distribution, right? So we also figure out all the values we need. So we already list all the values we need to find exactly three persons out of 5 know what Twitter is. So here, x value is a single value, is exactly 3 persons. So exactly 3 is a single value. So x is equal to 3. So next step, we're going to use the formula to calculate the probability. So here, we want to know the probability x equal to 3, or you can just write it like this. You can write probability x equal to 3 or p3. So that's the same meaning. And remember, 5 is our number of trials. We select 5 people. So total we select 5. We want to know 3 out of 5 people knows what Twitter is. So here we just plug it into our formula. But most important part, you need to know this is our lowercase p, means the probability of 1 success to the x. So success to success. So this is the probability of a failure to the number of a failure. So if 3 out of 5 knows Twitter, which means 3 out of 5 successes, 2 failures. So again, success to success, billion, 2 billion. After that, we round our answer to 3 significant digits. So this is the interpretation, the probability of getting exactly 3 adults who know Twitter among 5 adults is 0.138. Of course, sometimes it's almost impossible to use the formula to get the probability. Sometimes the n is too big, the x is not a single value. So we can use technology to help us to find the probability. Most of the time, actually, we will pick technology. But in our exam, we should learn how to use the formula to get the probability. So if we use the technology, there are several ways, several software will help us to get the result. The only thing we need to learn is how to read the output, right? How to read the output. If you already have the output, you should learn which one is you need. So let's check this one. Stat disk, we can input the number of trials here is 5, and we also need to input the lowercase p. The probability of a success is 0.885. After that, we will have the list, the table, the probability distribution, right? So if we want to get exactly 3 successes, so we need to check here, 3. X is equal to 3, so this is the px we want. So it's 0.138, right? Similarly, if we use Excel, we will check this one. If we pick the output of Excel and we check the x value, exactly 3, we find it's this one. And the corresponding p, x equal to 3, is 0.18. Similarly for the other output. So you need to find what you need in the whole output. Let's check another example. This is our chapter example. This is called overtime rule in football. So you can pause the video to read the question carefully. So after we read the question, we know this time we want to use the probability to talk about if 252 is a significantly high value. We focus on using the probability to determine a value is significant or not. So here, we just check, because we already suppose we already tested the results follow the binomial distribution, then we're going to use the binomial distribution to solve the problem, okay? So we want to use the probability to test the significance of a value. Remember? How can we use that rule? When we talk about significantly high, we should use this rule. If this value, or any even higher than this value, the total probability is less than 0.05, then we can conclude X is significantly high. So this time we want to test 252 is significantly high or not. So in this case, we only need to test the probability 252 or more is less than or equal to 0.05. So it's almost impossible for us to use the formula to do this kind of things, because here X is not a single value. X can be 252, can be 253, can be 254, and so on until 460. So actually 252 or more, we have 209 values, because from 252 until 4, that is the value from 252 to 53 until 460. We actually have 209 values, and we should find the sum of all the probabilities. Each time we should, if we want to use the formula, each time we should use a formula for one value. That means we should use the formula 209 times to get the value, which is almost impossible, right? So we should use the technology to help us. Let's check the output here. We want to test the 252 is significantly high or not, but actually the probability we need to do the to make the decision is not the single x value. It's not this one. It's not this column. We are talking about x or more, which means we should focus on the probability in this column. So 252. We locate 252 here, and we need to find the probability 252 or greater or higher or more. So this gonna be the answer we need to determine if 252 is significantly high or not. So make sure you pick the correct probability. Again, it's not the probability for the single x value. When we talk about significantly high, significantly low, it always should be the x, the probability of x or more, or ix or less. So for the significantly high, it's always x or more. For significantly low, always x or less. So we know this time we got 0.0224. If we already know the probability we need is 0.0224, and we compare it to 0.05, we know this one is smaller than 0.05, right? So what's our conclusion? We go back to check it here. If the probability 0.0224 is less than 0.05, then in this situation, we can conclude the 252 is a significantly high result. Yes, it is significantly high. So what does this mean if 252 is significantly high? Which means we get this kind of result is not by chance. It's unlikely to get 252 wins by chance, which means the result is not caused by chance. We can say the team wins the coin toss has a better chance of winning the game. So this number 252 is not caused by chance. It's reasonable to think if the team win the coin toss, will have the better chance to win. So basically, you need to understand we should use the probability to determine if a value is significant or not. Let's check another example. So this example is about the devil. So let's check 60% of the adults believes in the devil. So here, we will treat belief in devil as our success. So just like I said, the success is not necessary to be a good thing or bad thing. It's just tell you two classes. So here we treat belief in devil as success. Then this 60% we treat it as our success rate. So it's the lowercase p, the probability of a success rate, okay? We randomly select 5 adults. So you should understand that's the number of trial. N is equal to 5, right? And we will use the technology to help us to find the result. So the probability exactly 3. So the first, we want to know the single value, right? We want to get the single value of x to find the probability. Then we need to check part B, at least 2. At least 2. At least 2, which means 2 or more. 2 or more. So let's check the part A first. Just like I said, we randomly select 5 person and we know the X number is 3. Exactly 3 persons believe in devil. So we check the output here. Exactly 3. X is equal to 3. We can find the corresponding probability from this table. It's 0.346. So we finished the first part, right? We only need to know how to check the output. X is 3. Then we find the corresponding PX. Let's work on part B. The part B, we are talking about at least 2 persons. So this time, X is not a single value. At least 2. X is 2 or more. So we translate it to the symbol will be greater than or equal to 2. That is X can be 2. 2 is possible because we have equal sign, right? 2 or 3 or 4 or 5. See? We have 4 possible values for at least 2. Because we only have 5 persons in total, so the maximum number is 5. So 2 or 3 or 4 or 5. And the key words here is the or, which means we should use the addition rule of probability. Let's check. How can we do this kind of a problem? We should find the probability of exactly 2 people believing, exactly 3 adults believing, exactly 4, and exactly 5. So we go back to check the exactly 2, exactly 3, exactly 4 adults, exactly 5. And we should put them together to find the sum of all these 4 values. And the sum is the probability we need for part B. Okay, so if it's not a single value, something like at least, 2 or more, at most, no more than, that means it's not single value. We need to find all the possible values and find the corresponding probability, add them together to get the sum. The sum is the probability we need. So this is the first part. What is binomial distribution and how can we use formula to get the probability? How can we use the technology to get the probability? And we also talk about how can we use the probability to determine a value is significantly high, right? It's not use the single value probability.